yeah, we can move further to the last SDG, the 15, Life Above Land. And we have a presentation online from 𝗙𝗎𝗄𝗃 on the first service on the forest cover change, and later on there will be Melissa. So, 𝗙𝗎𝗄𝗃, can you hear us?
Oh, no.
Hey, 𝗙𝗎𝗄𝗃. Hey.
Can you see?
No, we don't hear you. Okay, now we see you well, and we be
Hello.
here. Yes.
Okay, so I hope you can see me. I'm going to share my screen.
Yes, we see you.
And can you hear me?
Yes.
Good. Okay, so this is my screen.
Okay, can you put in presentation mode?
Yeah.
It's perfect.
Okay, really happy to see you guys. Greetings from Brasov. So I'm going to present the service number 6, which is the forest cover change that we develop with the other partners that they are here on the first page. Now we follow the same structure like the other services presented before. So I'm going to start directly with the why. So the forest cover change. Why do we need this service? Well, it's one of the, let's say, the most common services that they are wanted from different stakeholders. And now we focused on filling the gaps in forest monitoring. With all the UDR and all the talk at the European level and national level, we identified that we still don't have a special detail and consistency on monitoring the forest cover change. Therefore, we focus on providing special explicit data. You know that we do have traditional data sets in different parts of the countries and worlds that they lack of geographic precision. So this was the focus on why building this kind of service, and of course to support the policy decision. Regarding the where, of course, Romania, it's a very, very good place to develop and to test this kind of service. We'll see why is that. We do have a complex topography and varied forests in types of disturbances. Therefore, this is something that we made Romania a very good pilot for this project. So how we did it? Actually, we implemented. We focused on analyzing the dynamics using vegetation index, so focusing on the quantity of chlorophyll that we see in the pixels. So we created a comparative analysis using multi-temporal satellite images. So we use Earth observation data, and we created a consistent workflow based on the standardized methodology. Of course, when we're talking about the forest cover change and monitoring, this is not a new type of service. So we already have different other experiences with building data, like involved in the Forest Path project, developing the European Forest Disturbance Atlas. And more than that, in Romania, we had this ground data validation from 𝗬𝗎 system, which is a unique monitoring system that is showing you the legal approved harvesting location. So the service has the scientific background, and combined with the co-design stakeholder engagement, starting with the first workshop in May in Brasov, and with other debates that we had with stakeholders, with academia. we came up to methodology. Of course, the methodology, we start with one version and then improve it. And after that, we move to the visuals and the interface, to working with 𝗙𝗲𝗰𝗸𝗲 and with Alessandro, and we developed the service itself. So the methodology is, this one has different steps. Is looking for different granules and is calculating the advanced vegetation index, and based on that is creating the changes map. But before that is calculating, it's classifying what is the forest cover. So in the end, we do have the change in the share of forest area. This is the workflow that happens under the hood. So we initialize the image collection and we apply the cloud mask, and then we extract the forest mask for the 2 periods, the before and after. And then we calculate all the composite images and the vegetation indices. So this is an example with brush over area, with the before and after advanced vegetation indices, and the forest calculated as a forest mask. And then inside identifying which is the change, if it is loss or gain based on the threshold that we cross-validated with our field data and the national inventories that we had. And in the end, we're creating this changes map and the change class distribution that is actually answering to our endeavor to provide a easy to use interface and statistics at different levels of interrogation. So I'm going to play 2 videos on the service demonstration. So first of all, the user interface. Again, thank you for the team who developed the interface. So we are selecting the dates, the before and after date, and after that we select a point. We try to be as fast as we could, like with the infrastructure that we have. So that's why we can do this at point level, and we create a buffer area. And in that buffer area, we calculate the vegetation index. Here is the before and after advanced vegetation index. And then we are calculating the differences. And in the end, you can download the data with the statistics and graphics that we're building in the portals. And yeah, of course, this is the results with the PNG data. So the user can use this information in their own reports, and the class distribution and what we come up from the interaction with the stakeholders. Now, regarding the platform itself, yeah, it's a Jupyter lab platform, and it is based on the Python. We try to make it as efficient as we could. So in here, the code it's explicitly comment, and it's using optimal computational power in order to find out where are the granules of Sentinel-2, to process them and to calculate the vegetation indices. And yeah, this is the raw the PNG's data that we are creating in the back, and this is how the user gets the information needed from our Jupyter lab. Regarding the key benefits and outcomes, we have an improved spatial precision. And of course, there is an enhanced temporal responsiveness. Like if we compare with other services, our service can be let's say, developed to answer quickly based on the data we ingest into the system. And in this way, it creates a fast response to the policymakers and to the actors. Regarding the sustainability, yeah, the workflows are published under the license of GPL. There is an interactive tool for calculating the share of forest area and changes, and the service can be migrated to the other host infrastructure to sustain the monitoring and consider SDGs indicators. And yeah, of course, challenges are always there. One of the challenges that I want to emphasize is time. That every time many algorithms that are appearing and they are better and better. The only thing that only disadvantage is that many of them they are requiring massive amount of computational power. So we believe that this kind of service can be applied on a simpler solution in terms of computation, and it is both a challenge and an advantage in the same way. Thank you for listening me and waiting for the questions.
Thank you, may I? Question 4, may I? I have one question about the spatial resolution of the final map. Is that the spatial resolution, the accuracy is the accuracy of the base map of you use for the classification, or you do some downscaling of the data? So which is the final spatial resolution of your map, land management, like map, change by map?
So of course we do have two spatial resolution that we work with in Sentinel-2. The vegetation index we calculated 20 meters because it's faster, but we do have the option for the 10 meters too. So for the forest map, which is not let's say computational intensive, we are using the 10 meters. And for the advanced vegetation index, we are using the 20 meters.
Okay, thanks. Other comment or question for me? No. It might be that later on, after also the presentation of the second part of this pilot 4 and the presentation of the service from Melissa on the soil erosion by water.